Good morning, guys. April, we made it. Let's take a look at today's lesson. How can we prove quadrilaterals are parallelograms? First, the do now. Make sure you're taking a look at these do now questions before you see the video. Alright. A regular decagon is rotated n degrees about its center, carrying the decagon onto itself. The value of n could be. Alright, rotating a polygon onto itself is 360 degrees. Divided by the number of sides. For the decagon, we have 10. That would be 36 degrees. You see that's not one of our answer choices. This is the minimum degree of rotation to get the polygon onto itself. Now if we went another 36, alright, that would map onto itself. Another 36 would map onto itself. Another 36, and you just keep going with that. Okay, and eventually you see our answer choice of choice 4. Just keep in mind 252 divided by 36 comes to a nice whole number of 7. Alright, a little review of rotating a polygon. Okay, next, number 2. The graph below shows two congruent triangles, ABC and ABC prime. Which rigid motion would map the triangles onto each other? Alright. So, this would be choice 4. A reflection over the line y equals x. Remember what that line is. If you're not sure, you can throw it in your calculator. Y equals x is this line right here. Okay, the triangle will flip over that line. None of the other answer choices are sufficient. Remember, you can check if you thought it was one of the rotations, you can check one of the methods, perhaps connecting B to B prime through the origin. Okay, you can see that that angle measurement is not 90 degrees, it's not 180 degrees. Okay, and you'll get something much different if you did it for, let's say, A and A prime. A and A prime. Okay, that's some acute angle. The other one was obtuse. Okay, a rotation would not be appropriate here. And that translation you can go through, for A to A prime, see 3 to the left, 3 up. You'll see it will not work. But we end up with choice 4. Okay? Now, remember your steps for a coordinate geometry proof. Today we're proving parallelograms. Plot the triangle, find all the slopes, find all the distances, which is the length of the sides, and then writing the explanation is what gets a little bit tricky. You just have to think about what you're proving and how you can accomplish that goal. Today, once again, you're going to see plotting the triangle, finding all the slopes, and then writing the explanation. That will accomplish our goal. Remember to guarantee yourself the most amount of points possible on a Regents exam. You should also find all of the side lengths. But our goal will be accomplished today through slopes. Okay, think about proving something's a parallelogram. Think about what word. Today we're not going to look, if you read the sentence, how do we prove a quadrilateral is a parallelogram. We won't be looking at trapezoid today. But proving something's a parallelogram, what word is in parallelogram? Right, parallel, guys. We're going to show the opposite sides are parallel. How do we show on a coordinate grid, how do we show lines are parallel? Slope, okay, same slope. And that will accomplish our goal. So if you fill in the blanks here, alright, we're going to show two pairs of opposite sides are parallel by using the slope formula 4 times. Now you don't have to actually use the slope formula. Remember, we can count the boxes. How much do we move up and down? How much do we move left and right? And that will give us our slope. Okay, slope formula 4 times. We'll see the opposite sides have the same slope and are therefore parallel. All right, we know the opposite sides are parallel when they have the same slope. So we've been dealing a lot with opposite reciprocal slopes to show perpendicular lines and a right angle. Now we're going to be showing same slope to show lines are parallel. If opposite sides are parallel, it's a parallelogram. So example 1, you see what we have to prove. Prove it is a parallelogram, straight out. I plotted the triangle in advance. So once again, slope 4 times. Let's look at a side length. Let's find the slope of AB. Up 1, 2, right 1, 2 over 1. Now let's look at a side length that's opposite that. DC. Up 2, right 1, 2 over 1. From this info, this is really what I want you to see here. From what we just did there for finding the slope of AB and DC, we just found that AB is parallel to DC. Okay? Now the other pair of opposite sides, the slope of BC. Now that's just a flat line running horizontally. That would be a 0 slope. The slope of BC is 0. And the slope of AD is also 0. What we can conclude from that, which is great to write down here, BC is parallel to AD. They have the same slope. They're parallel. Okay? The explanation now. This is what gets a little bit tricky, but just think logically about what we did. We showed opposite sides have the same slope and are parallel. Therefore, it's parallelogram. So since both pairs of opposite sides have the same slope and are parallel, ABCD is a parallelogram. Alright, since both pairs of opposite sides, right, both pairs, not just one pair, both pairs of opposite sides have the same slope and are parallel, it is a parallelogram. Let's try another one, example 2. Given, right, quadrilateral ABCD with the vertices ABCD, you can see as follows. Prove ABCD is a parallelogram. Same procedure. Parallelogram, what do we know? Opposite sides are parallel. We can show parallel on the coordinate grid. That's why our focus is slope. We can show the opposite sides are parallel through same slope. So pick a side length. The slope of, let's say, DA is equal to up 1, 2, 3, 4, 5, 6, right 2, 6 over 2, which will simplify to 3. Now let's focus on the side length that's opposite that, which would be CB. We'll show that that has the same slope, up 1, 2, 3, 4, 5, 6, right 2. 6 over 2 simplifies to 3. Now what can we conclude from that? That DA is parallel to CB. Remember, you can write a side length either way. You could write DA, AD. You could write CB, BC. It does not matter. Okay, and our other slope for, let's say, AB. Look at that line. That line will have a negative slope based on how that line looks. But it'd be down 1, 2, 1, 2, 3, 4, 5, 6. Right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 6, right 10. Which will simplify to negative 6 over 10, negative 3 over 5. And our slope for DC should be the same thing, right? Down 1, 2, 3, 4, 5, 6. right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 6, right 10. Simplifies to the same thing, negative 3 over 5. What can we conclude from this? AB is parallel to DC. So we, through slopes on the coordinate grid, we showed that both pairs of opposite sides are parallel because they have the exact same slope. Now guys, I like to give you explanations that are always going to work. This is a perfectly fine parallelogram explanation as long as we show this work. Since both pairs of opposite sides have the same slope, and are therefore parallel, quadrilateral ABCD is a parallelogram. Okay, so what you're going to do is give example 3 a shot. Okay, please send me questions and remind. Don't forget Delta Math is due tomorrow. It's already Wednesday, so you have today and you have tomorrow, but Delta Math is due at 8 o'clock tomorrow. Make sure you take care of that. Have a wonderful rest of your day, and I'll see you mañana.